Welcome back to the latest IGCSE and O-Level past paper video. In this video we're going to be covering paper 22 again from May-June 2025, and as always if the video is too slow then you can watch at 1.5 or 2 times the speed, and of course as well as watching the video I will also recommend checking the mark scheme just so you can see the full list of acceptable answers. Right, so question 1 says tick one box to complete the description of abstraction. Right, so abstraction is part of the analysis stage of the development life cycle. Okay, so let's try and actually kind of create this definition in our head, and then we'll see if any of ours match the ones that they give. Alright, so I would say the definition of abstraction basically is about removing the unnecessary detail so that you're left with a simplified, kind of easier to understand problem. So if we sort of look at the first one, right, testing the solution to the problem, why I guess that's just testing. Right, okay, writing a program using program code, well that's in the development stage, or the coding stage. Right, then C, defining the subsystems that make up the problem. Right, so that seems more like decomposition, where you're taking the big problem and then you're breaking it down into the individual sub-problems. And then D, so removing details from the problem that are not relevant. Okay, so I think this is the one that most closely matches what I said. Alright, and if you think of the example from the book, I think maybe this is in the AS book, or I'm not sure about the IG book, the example they have. But in the AS book they have quite a nice example where for abstraction they basically use an example of a map. Alright, and this could be a subway map, it could be a tourist map. Now if you were to use like the super detailed real map, well of course you're going to have thousands of roads, all these different all these different like signs, right, all these different parks, right, different shops, all of this stuff on the map. Now in reality that's going to be quite complex. Whereas let's say you're just making a subway map, or if you're just making say a tourist map where you just want to have kind of like the main roads, right, the main tourist attractions, you don't need like all of the individual corner shops, right, you don't need all of the individual little roads. So that's kind of what we're saying about abstraction, right, we're just removing the unnecessary detail just to kind of give a simpler problem, or like a simpler solution left at the end. Right then, to a fence measuring 2 meters in height and 20 meters in length needs painting. The area of the fence needs to be calculated so that enough paint for the job is purchased. Right, after the task is decomposed, so again we're broken down into smaller sub-problems. Right, there's 3 component parts: input, process, output. So just IPO. Right, 3 component parts and 4 example descriptions are shown, and we want to draw one line from each component part to the most appropriate relevant description. Right, not all descriptions will be used. Okay, so actually this question is a little bit strange, it's kind of different to what they've asked previously. So I think first of all let's just read the descriptions. Right, so the height of the fence, the length of the fence. Right, then the next one, the amount of paint required is 40 square meters, right, the colour of the paint, and the area of the fence is calculated as 40 square meters. Alright, so basically if we think back to the original problem, well, it's saying we've got a 2 by 20 meter fence, and we need to calculate kind of how much paint we need, right, in order to paint that. So I think if we look here, input, right, then I guess the 2 variables that we need to input, right, that's going to be the height and the length of the fence. That seems to make sense. Right, then if we think process, so process, well that's going to be some sort of calculation, right, some kind of assignment. Okay, so kind of something like that. Alright, so I think that's going to be this one. The area of the fence calculated is 40 square meters, because I guess here they've done 2 times 20. Right, then if we say output, so I think that's going to be this one here, right, so the amount of paint required is 40 square meters, so just kind of returning that or outputting that to the user. Alright, and again, this question is actually a bit strange, because honestly, like so these two here are quite similar. However, I guess the difference, because this one says calculated, right, therefore we think it's process, whereas this one is just saying, well, the amount is 40 square meters, right, therefore that sounds like it's probably something that's going to be output to the user, just notifying them of this result. Right then, 3, so a range check is used to validate that the input temperature is an integer between -100 and 0 inclusive. Right, suggest suitable normal, abnormal, extreme and boundary test data to test if this validation check is working correctly. Okay, so if we say normal, well basically this is obviously just kind of valid data, right, something that's in the range. So I guess here we can really say anything, from obviously sort of -100 to 0. I mean, to be honest, right, let's just go something safe, let's just say 50. Because I guess technically, right, so if you said -100, well, that would be normal. All right. However, that would also be extreme. Yeah, that would also be, you know, 1/2 of the boundary. So I think, yeah, for normal, just go with something in the middle. Right, if we say abnormal, well, let's go something outside of the range. Now, again, you could say, for example, minus 101. You could say, yeah, I guess sort of 1. However, again, you know, both of those would also be considered boundary. So I think here, let's just go like minus 200. Right, so something that's way outside the range. Right, if we say extreme, and yeah, do we need just one or do we need both? Okay, right, it says suitable, so I think probably just one is going to be okay. Yeah, alright, so, yeah, okay, right, so let's say for extreme, then, well, here we can just go minus 100, right, we could also go 0. So if we think about extreme, this is basically the smallest value that's acceptable, right, yeah, or the biggest value that's acceptable. So of course here we'll obviously get minus 100 and 0. Right, then if we say boundary, so boundary is going to be in a pair. Now if we say the lower boundary, well, this will basically be the value that's kind of just too small. So yeah, the value that's, you know, just kind of abnormal. Alright, and then also the extreme. Alright, so if we want the lower boundary, well, that's going to be minus 101. Alright, and then I guess also, yeah, also minus 100. Okay, because what we're saying is that, well, minus 101 is going to be abnormal, right? That's not accepted. But then, yeah, obviously minus 100, well, that will be accepted. Okay, yeah, okay, right, so hopefully that makes sense why it's called boundary, because, okay, yeah, alright, so basically we can draw a line between those, where we say kind of everything to the left is going to be not accepted, I guess where everything to the right sort of will be accepted, of course, yeah, up until we hit the upper boundary. Alright, so the upper boundary, I guess, well, that's going to be 0, so of course, yeah, this is accepted, right, kind of, yeah, to the left is accepted, and then obviously everything to the right, well, that's not accepted, for example, 1. Alright, so yeah, hopefully that makes sense what boundary data is. And I think here we can probably just give one pair. Right, so yeah, either you'd say minus 101 and minus 100. Right, yeah, or you would say this pair here. Right, then the next one, and I think, yeah, let's try and type this. So state one reason for using a verification check when inputting data. Alright, so I guess we can say what, just to check the user has entered the data correctly, to check they've not made a typing mistake, for example. Let's say that, yeah, yeah, I guess check is okay. To check that the user has correctly entered the data. Right, let's say, yeah, e.g., right, yeah, no, maybe right, that they haven't, right, made a typing mistake. Yeah, I guess, etc. Yeah, I think that should be fine. Right, so then B, we want to write pseudocode for an algorithm to perform a double entry verification check using the following criteria. So we want to input 10 numbers and store them in the array numbers. Then we input the same 10 numbers again, right, as each number is input. We want to compare it with its corresponding number in the array numbers. Right, if the numbers match, then move on to the next number. If the numbers don't match, then display both numbers and ask for the number to be re-entered. Right, then we want to store and re-enter. Okay, yeah. So sorry. Right, store the re-entered number in the corresponding array location and move on to the next number. Alright, so I guess what we show them both numbers, right, ask them to re-enter, and then we just kind of accept their third entry regardless of what that is. Right, then when all the numbers have been checked, display a message to say the check has been complete. Right, you do not need to declare any arrays or variables for this algorithm. Okay, so I think I'm just going to open this in the app and yeah, let's try and code it there. Okay, so there's not too much here, I think just one array. However, if you do want this starter code, of course, go here, go exam questions, and then yeah, you can just, you know, get this declaration already. Alright, and I've gone ahead and also just copied the question. Now, I think what I might do is, rather than looping to 10, because that's going to take quite a long time to test, then I'm just going to make that array size 3. Yeah, just so of course it's easier to test, right? We're only having to enter 6 entries, yeah, rather than having to enter 20, you know, since it's of course a double entry. Right, so first thing what we want to do, we want to input 10 numbers and store them in the array. So, yeah, okay, right, now, okay, yeah, so in the question it says we don't have to declare. I mean, actually for loops we also don't have to declare either, really. So let's just go next then, and let's just start that at 1, and let's go to 3. Now, of course, obviously in the exam you'd want to go to 10, but yeah, since I'm just, you know, made it, well, sort of shorter to test. Alright, and then I think what we can do, let's have a message, let's say, yeah, please enter, I don't know, yeah, like number, and let's go n. So obviously, yeah, like please enter number 1, please enter number 2. Right, then we just want to input that, and we're going to input into numbers right at the index n. Yeah, that should be fine. Yeah, okay, right, yeah. So what they're doing is we're not kind of inputting number one, then input number one again. Right, we're actually inputting, right, number one, number two, number three. Then once we've input all of those numbers, right, then we go back and then we have another loop. Alright, so I think here we just need to end that loop. Right, then basically we're just going to sort of copy the same thing. So I'm just going to copy that. Right, and what we then want to do, yeah, okay, right. So here, of course, we can't actually input into the array. Because otherwise that's going to overwrite our existing value, and then we won't be able to compare right, the value they've just entered, you know, of course, right, with the value in the array. So what I'm going to do, let's declare, and I guess let's go temp. Right, that's going to be an integer. Right here, let's just input into temp, and basically we want to check that if temp is equal, right, to the current number. So let's go that, right here, yeah. And I guess actually, since we're of course asking them to re-enter if they do it incorrectly, well, let's check if it's not equal. So let's get if temp is not equal to numbers index n. Right, then I think it says we want to output both numbers. Yeah, so display both numbers and ask for the number to be re-entered. Right, so let's do that. Let's say error. Right, okay, yeah, alright, so let's say maybe you entered, I don't know, 5 first, but entered 6 the next time or something. Yeah, or let's say that, okay, right, let's say the first time you entered, and let's go right, numbers n. Alright, let's say, yeah, while the, I don't know, yeah, okay, right, while the second time, alright, the second time you entered, and right, that's going to be temp. I know you're right, let's say, I know, yeah, please enter, yeah, right, okay, let's say what, please enter another number. Yeah, okay, alright, okay, yeah, let's say, I know, please enter again, right, to confirm or something. Yeah, that should be fine. Right, then let's input, and to be honest, it's kind of a terrible error message, but yeah, it doesn't really matter what you say. Right, okay, then here I think we can then just input directly into numbers n. Alright, since whatever they enter on this third time, well, that's going to be accepted, right, so store the re-entered number in the corresponding array location. Right, then when all the numbers have been checked, display a message to say the check's been complete. Alright, so that's going to be outside of the loop. And let's go, I don't know, yeah, double entry check complete. Yeah, that should be fine, I think. Right, so let's get into number one. Let's go 5. Right, let's go 6, and let's go 7. Right, okay, and okay, yeah, so this time let's say 4. Of course, this is going to be wrong. Yeah, so the first time you entered 5, right, the second time you entered 4, please enter again. Right, I don't know, let's go like 9, for example. Right, and then I think, what, 6, and then 7. Yeah, okay, right, then double entry check complete. Right, of course, the first time it asked us to enter again. And yeah, the second and third time, well, since we entered the same, alright, therefore it didn't ask us to re-enter. Okay, yeah, so that's fine for that one. Right then, number 5, the pseudocode algorithm should allow 500 names of people and their heights to be entered and stored in a two-dimensional, two one-dimensional 1D arrays. The name of a person and the height of that person are the same index in both the names and heights array. Right, so there's quite a lot here. The algorithm performs as follows. So at the start, the following data is entered: the name of the person and the height of the person in centimeters. Right, the data is stored in the relevant arrays. The heights of the people are totaled. The shortest person is found, and at the end, the following is output. Right, the name of the shortest person, the height of the shortest person, and also the average height of all 500 people. Right, okay, yeah, so what we want to do, we want to identify the line numbers of 5 errors in pseudocode and suggest a correction for each error. Okay, right, so let's maybe use the pen, and yeah, okay, right, so what I always say is with this, first, you know, just try and find all the 5 errors, right, then once you're confident you found like all of the correct errors, well, then sort of start writing. Alright, because what other people, yeah, okay, right, so what some people do is they think they find an error, right, then of course, you know, they start writing it here in the correction, right, but then when they get to the end, well, suddenly now they think they found 6 errors, alright, so of course, yeah, one of these things that they thought is an error is actually not an error. So yeah, I think, okay, yeah, so that's why it's good to actually sort of, you know, read through the whole thing, yeah, make sure you found the correct errors first, right, then start writing it. Okay, so yeah, let's sort of read through line by line. Right, so first of all, declare names, array 1 to 500, that seems correct. Okay, but then if we look here, right, this says real. Now, of course, if we think names, well, obviously, yeah, names is going to be a string. All right, so I think, yeah, let's highlight this. This will probably be our first error. All right, the next one, heights, right, array 1 to 500 of real. I mean, that seems okay. Yeah, I guess heights we don't really want to be an integer, right? Of course, you can have a decimal value. Right, shortest is real. I guess, yeah, that's going to be the height of the shortest person. Right, total is going to be a real. I mean, yeah, that makes sense, because if we think, well, the heights is going to be real, right, therefore, of course, you know, total also has to be a real. Yeah, since we're just adding those heights. Right, counter, so I guess, yeah, counter is just this for loop counter, right, that's an integer, yeah, that seems correct. Right, declare index, integer. Right, so what's that index going to be? Yeah, right, okay, yeah, so I think what they're saying here is if we look at this, basically yeah, okay, right, the index, this is going to store the index of the shortest person. Alright, because I guess here we're checking, right, if the height they've just entered is less than the shortest, well, then they're going to assign this height they've just entered, right, to the shortest sort of variable. And then I guess the counter, right, so this is, well, the current loop, right, the current loop counter, they're going to assign that to the index. Right, so the index, yeah, okay, right, yeah, okay, so I guess here we can see it, where the index is basically the index of the shortest person. Yeah, so I think, yeah, okay, right, so I think index being an integer, that seems fine. Right, then on line 7, so shortest they assign 500. Yeah, I mean, that seems okay because I guess, well, of course, everyone is going to be shorter than 500. Right, now if, for example, you assign shortest to be 0, well, this will be a problem. Alright, because then, for example, when we have this condition, well, let's say they enter, I don't know, height of like 170 or 175. Well, then when we check this, you know, is 175 less than shortest? Alright, well, of course, that's going to be false. Yeah, since we've assigned shortest as this, you know, a sort of 0 on the default value. Alright, so I think, yeah, assigning it 500 is quite good. Right, so then, yeah, index is going to be 0. I mean, that seems like it should be okay. Right, then we say 9, right, so for some reason they've started total at 100. However, I guess really this total should start at 0. So yeah, I think that's going to be our second error. Alright, because this is just adding up the total of everyone, or, you know, everyone's height. And then I guess, yeah, obviously at the end, right, they do total divided by 500, or of course divided by the number of people, in order to calculate the average. Okay, so I think, yeah, that's 2 of our errors, right, then we go for counter 1 to 500, I mean, that seems okay. Right, we then input into names index. Okay, so I think that's wrong because if we see here, well, counter is actually the for loop variable. So yeah, this is going to be our second, oh yeah, okay, right, this is going to be our third error. Right, then the next one we input into heights counter, I mean, that seems okay. Right, then 13, so total is going to be counter plus the heights counter. Right, so I think that's going to be wrong. I think this heights counter is correct. But then, yeah, okay, right, okay, yeah, so this one here, right, this should be total. So it should be total and then assign total plus heights counter. Alright, because of course, well, total is the previous total. Then obviously, yeah, heights counter, well, that's the current height that they've just entered. Right, then 14, so if heights counter, right, so the current height, if the current height is less than the shortest, right, then we assign the current height to be the shortest, and we assign the counter to be the index. Yeah, I think that's okay. Right, then of course, just make sure that you have the end if. Yeah, that's fine. Of course, that closes there. Right, then next, yeah, obviously counter, right, that also matches up. Right, then 20, so the shortest height is, and then heights. Alright, so because this is a 1D array, well, therefore, of course, we also need this index here. Alright, and I think, yeah, that's going to be our 5 errors, right, so obviously 1, yeah, 2, 3, 4, and yeah, 5. Of course, yeah, 4 being this one here, this counter. Alright, so I think, yeah, okay, right, so what I'm going to do, because it's on obviously 2 different pages, that's going to be annoying having to sort of scroll up and down. So I think I'm just going to zoom out and then I'm just going to write them here. Yeah, just in this blank space. Right, okay, so the first one, right, that's going to be line 1. Write the error. And I guess we have to write the whole code. Yeah, okay. Alright, yeah, okay, so because here it says suggest a correction, then it doesn't actually say, you know, rewrite the line. So I think here we can just explain it. Right, let's say, yeah, names array, right, should be, I don't know, yeah, let's say, right, of type string. Although, to be honest, actually here, like, by the time you've written that, I mean, it's probably easier just to rewrite the whole line anyway. Let's go, right, the next one then is going to be, what, line 9? Right, okay, let's say what total total should be initialized to 0. Right, then the next one's going to be line 11. Right, so here I guess what counter is the current, the current kind of person index. Right, let's say that counter should be the current, I guess I know, the current person index or the current name index. Right, let's say IE. Right, let's go input, and we're going to go what names counter. Right then 13. Alright, and I think 13 is going to be easier just to kind of rewrite the whole line, rather than actually trying to explain this since it's quite long. Right, so that's going to be what total plus. Then we want to go heights right at the index counter. Right, and then I guess just one more. So yeah, that's going to be on line 20. Right, okay, yeah, alright, so let's see what heights, is a 1D array. Right, hence we need to output, the height of the shortest person. Right, let's say, IE, heights, and then at the index. Okay, although, again, to be honest, it's probably quicker just to, rewrite the whole line, rather than trying to explain it like that. Right then for B, we want to write the pseudocode statement that will output the average height rounded to 1 decimal place. Right, okay, so in order to do that, and right, I guess we want to output as well. So let's go output. Right, let's go what average height. Right, and then so here then we want to use the round function. I think they said what is the total divided by 500. Right, although of course that's going to be a real. And then if we want to round it to 1 decimal place, well then we just use 1 as the second parameter to this round function. Alright, and I think let me just demonstrate that, right, if people are confused. So let's go output round. Let's say we have, some number, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so here then this takes 2 parameters. Now if we round it to 0 decimal places, well that's going to round it to 123. Right, of course, so just a whole number. Right, if we round it to 1 decimal place, well, I guess that's going to be 123.5, because I guess, this 4, 5 is going to get rounded up, right, and then of course we're rounding it to 2 decimal places, kind of etc. like that. Alright, okay, so, so hopefully that makes sense, kind of how that works. Right then C, we want to explain how we could change the corrected algorithm so that it will also find the height of the tallest person and output the height of the tallest person at the end of the algorithm. Right, so any program statements used must be fully explained. Okay, so this is actually quite easy since they've already done this for the shortest person. Therefore, we can basically just copy the same code, right? Just try and explain it again. Alright, so I'm going to go up here and I think, I'm probably just going to write it here. Right, so what we can do, I guess, well, first then we just want to declare an index. Right, okay, so same as like they've done on line 6. So let's say, right, declare declare a tallest person index. Or let's say, and initialize it to 0. Right here, then I think we can say inside the loop we want an if statement. I'm checking that if the current person is taller, right, than the tallest person. And I guess actually we also need to initialize a tallest value. And I guess we can initialize that to be something short, for example 0. Right, so let's say declare a tallest person index and initialize it to 0. Right, let's say as well as a tallest height. Right, let's say tallest height, real number. Right, let's say initialize it, I guess, to 0 as well. I think that makes sense. Alright, and so let's explain why we initialize it to 0. Right, let's say since, and I guess we can say since otherwise, alright, so what I want to say is, well, otherwise basically the if statement is always going to be false. However, since we haven't mentioned the if statement yet, maybe it's sort of not good to sort of kind of hint at that. Alright, so I guess we can say, I don't know, since, alright, so I think probably let's just mention the if statement. Right, let's say since otherwise, the if statement, right, the if statement, let's say used to check, right, if the current person is taller, right, let's say, yeah, might always fail. Yeah, okay, right, might always fail if a high value, right, is kind of initially used. Yeah, I think that's fine. Right, okay, then let's say inside the loop, right, inside the for loop, right, let's say inside the for loop adds, yeah, I don't know, yeah, add another if statement, right, checking if the current person, yeah, okay, right, if the current person's height, right, is taller, right, I guess, well, yeah, sort of bigger, or I guess more, right, let's say it is more than the, I don't know, yeah, current, let's say, okay, right, the current tallest, I don't know, sort of, I don't know, yeah, variable value that we found. Yeah, okay, alright, yeah, okay, let's say if it's more than the current tallest value, right, that we have found. Right, okay, yeah, let's say, right, if it is, then, right, okay, yeah, and this is basically what they've done on lines 16 and 17. Right, then we can, right, let's say, yeah, we can assign the, okay, right, let's say assign the current person's height, right, to the tallest, I don't know, yeah, to the tallest variable, right, and also, right, also assign the current counter, or in fact, yeah, okay, alright, so I think here we can just say counter, and yeah, let's just use uppercase, just so, you know, they sort of know it's the same as the variable. Right, and also assign the counter, or yeah, the counter's value, right, to the, I don't know, yeah, tallest person's index. Alright, and I guess we can say, I don't know, yeah, like they have done, right, for the shortest, yeah, I know, the shortest person check. Yeah, I mean that should be okay. Alright, and I think here they give us, yeah, okay, yeah, they give us quite a lot of space to write that. So yeah, they're looking for quite a lot of detail, I think. Right, then if we look at number 6, so this pseudocode is an algorithm, and I guess, yeah, maybe we can sort of have a read through it first. Right, so first they're just declaring a load of stuff, right, word, well, v1, v2, right, integer. Yeah, I guess they got some more, well, yeah, some more integers, right. Obviously, it's, well, L1, L2, just characters. Alright, and then, yeah, here they've got some flag, right, just called continue. So first they're going to input a number, and then they're going to loop up until that number. Right, okay, then they're going to input a word, and right, they're assuming that this flag is true, right, so this continue is true to start with. Right, then they're just going to assign v1 to be the start, right, they assign v2 to be the length of the word, right, so let's say they enter, I don't know, A, B, C, D, E. Right, so, yeah, okay, right, so, okay, v1 is going to be the start of the word here, right, v2 is going to be the end of the word, like that. Right, so then they're going to loop, right, while continue is equal to true and v1 is less than v2. So yeah, again, right, this is going to be v1 here, right, this is going to be v2 here at the end. Right, so if L1 is not equal to L2, alright, and I guess what they're doing, so L1 is the substring, and right, so, okay, yeah, so here they're starting index v1, right, of course that's here, right, then they're getting one character. Right, so that, okay, yeah, that, okay, that's going to be this A. Right, then for L2, right, they're starting at V2, again, they're getting one character. Right, yeah, okay, right, okay, yeah, so that's going to be this C. Right, so if L1 is not equal to L2, so in this case, well, A is not equal to E, right, then continue is false. So I guess, yeah, if the characters are obviously different, right, then it's just going to stop looping. Right, however, if they're the same, well, then what happens is V1 is going to plus 1, right, so basically V1 is then going to go to B. Of course, well, v2 is going to minus 1. Of course, well, v2 then goes to d. Right, and yeah, I guess then they're just going to try and loop again. Right, of course, continue would be true, you know, if the characters were the same. Again, yeah, v1 is less than v2, right, that continues. Of course, it's going to check if those characters are equal. Right, if it is, then it's going to continue looping. Right, yeah, okay, right, so, okay, yeah, so maybe, like, people might have figured out what this is doing. Basically, it's just checking if it's a palindrome. So when we say a palindrome, well, that's a string that reads the same forward as backwards. Alright, so if you reverse the string, it's going to be the same. Yeah, okay, so for example, something like kayak. Alright, so of course kayak, well, yeah, K-A-Y-A-K. Right, okay, that's going to be the same as if you read it, obviously here, you know, K-A-Y-A-K. Right, it's, yeah, the same in both directions. Right, okay, so then we just want to complete the trace table for the algorithm using the input data. Alright, so probably you can figure out actually that race car, well, this is going to be a palindrome. So assuming there's no mistakes in the algorithm, I mean, this should say true. Obviously treat, well, that's not going to be. Right, therefore, yeah, that's going to say false. Okay, so I've gone ahead and just split screen it just so it makes it easier, easier for us to do this. Right, so I guess first then, if we just go down here, right, okay, the first thing is going to be input, is going to be the number. So, right, let's just input that 2, right, of course, that's the first input here. Right, okay, then we're starting the loop, so we should probably start a new row in the trace table. Alright, and this is something that people often ask, when to start a new row in the trace table. Actually, what the examiners have said is that it doesn't really matter, when you start a new row. Alright, because what they're really going to do is they're going to check the columns. So as long as you start a new row kind of in a sensible position, right, for example, each time you start a new loop, right, or if the value has changed, compared to what it was previously on that row already. Alright, however, so sometimes, for example, they start a new row inside an if statement. Now, if, for example, you didn't, well, that's not going to matter. Alright, so what I would say generally, just start a new row inside each loop. And of course, if the value has, sort of already been set on that row currently. Right, okay, so what we can do, right, so index is going to be 1, just looking at this, so let's go here, index is 1. Right, then they're going to input the word, right, so that's going to be race car. I guess it's a bit difficult to kind of write it there. Right, right, and to be honest, I guess we should also do the uppercase. Alright, since of course here it's uppercase as well. Alright, and actually so for this one it's going to be important that it's uppercase. Alright, since of course when we do this we get the substrings. Well, then of course when we compare them, now if for example we compare like big R, obviously big R and then small r. Alright, so here of course they're not going to be equal. Since of course obviously big R is some ASCII code, or obviously small r is going to be some different ASCII code. Right, okay, so then they set continue to be true. So let's just write that here, right, true. Right, okay, so v1 is going to start at 1, right, v2 is going to be the length. So I think race car is that 7. That's going to be 7. Right, okay, and then actually, so here we could start a new row if we want, since, of course here we're sort of going inside another loop. So I think, maybe I'll just start a new row. So, right, then L1. So L1 is going to be substring, right, basically the first character. So I think let's go here, right, that big R. Right, okay, so L2 is going to be the last character, of course, that big R as well. Right, okay, so, alright, although actually I think I've just realised that if I start a new row here, then I don't think we're going to have enough space, just kind of considering how many characters this is, right, and then of course how many characters this is. Although to be honest, I guess this actually should terminate right when we get to the RNA. Alright, but I think, maybe let's go ahead and just erase that. And then I'm probably just going to put those put those R's on the row we were currently on. Alright, because I think otherwise it might not fit. Right, okay, there we go. Okay, right, and also something that is important is that I think generally they are looking for you to kind of use the correct, I guess the sort of correct, the correct quotes. Alright, and actually thinking about it, so even though it's only one character, I think substring is going to return a string, right, therefore even though it's only one character, we should actually have the double quotes. Right, so continue, right, so continue is still going to be true because of course we're in this one. Right, then what we say, right, so basically v1 is going to increment, right, therefore v1 goes to 2, alright, v2 is going to decrement, right, therefore that's going to go to 6. Right, then we're going to obviously go back here, we're going to go back to the start of this loop. Okay, so continue is still going to be true, right, obviously v1 is less than v2, right, that's also true. Right, then we're going to get the next character, so the next character, that's going to be 2 A's. So let's go, obviously A, again, right, that's going to be a string. Alright, and then, I guess then again, we're just going to go here. So, right, that's then going to go to 3, this is going to go to 5. Right, then we're going to have, I guess, what, C's? And again, right, then we're going to go back. Of course, continue is still true, right, v1 is still less than v2. Right, then what's going to happen, right, so 3 and 5. So 3 and 5 is going to be these C's. Alright, so then I guess what's going to happen, right, this v1, well, this is going to go to 4. Right, okay, that's also going to go to 4. Alright, so, yeah, okay, right, so because it's 4, well, now, of course, this condition is going to be false. Alright, yeah, okay, yeah, and what this is saying is basically, if we have a string that has an odd number of characters, well, we actually don't have to check the middle character. Alright, since, yeah, okay, right, so basically there's kind of nothing to compare it with. Yeah, so let's say we have, I don't know, yeah, okay, right, okay, so for example, like mum, right, just a three-letter palindrome. Well, of course, right, first we have to check the M and the M, right, and then, yeah, okay, right, so once we've actually checked that, well, once we get to the middle, of course, kind of, yeah, by default, well, it's going to be symmetrical both sides, yeah, since there's only one character in the middle. Alright, now if, for example, we have, I don't know, some, like, sort of four-letter palindrome, yeah, I'm trying to think of an example. I think, okay, alright, yeah, I think let's just go like ABBA. So obviously like ABBA, the music band. Alright, so I guess ABBA, yeah, so what we need to do, of course, well, first we're going to check A and A. Alright, but because this is 4 letters, because it's even, well, then, of course, we do still need to check these middle two. But yeah, of course, right there, yeah, they're going to match. And of course, yeah, that's also going to be here, right? Because in this case, we would say, well, V1 is going to be 2, right? Sorry, yeah, V2 is going to be 3. And yeah, that's going to be these two B's here. Yeah, so I think that should be fine. Right, so then what happens, we kind of exit the loop, because of course, yeah, this one is going to be 4 and 4. So right then we just want to say, right, successful. And I think here, yeah, maybe let's just go to a new line. Right, successful. Yeah, right then what we need to do, I guess now then we need to go back, obviously, yeah, we go to this next index, right, therefore we go back to the top of the loop. Right, so now the index is going to be 2. Again, yeah, starting a new line since we're, you know, starting a new loop. Right, then we're going to input words, so that's going to be treat. Right, and then here, so continue, again, yeah, well, continue is going to be true. Alright, I think even though technically that hasn't changed, I think I'm just going to sort of do it again, yeah, since we're just kind of reassigning it, basically. Right, so V1, well, that's going to be 1. Right, that's going to be length of word, right, that's going to be 5. Right, so then, yeah, obviously, well, continue is true, obviously V1, yeah, 1's less than 5. Right, so here then we're on this L1 again, and right, that's going to be this T. Right, and then, yeah, I guess that's also going to be T here, right, the ending character. Right, then if we go, yeah, here, so, right, okay, then we're going to go V1 increment. So that's going to go to 2, right, V2 is going to go down to 4. Right, then the next characters, that's going to be R. And, yeah, I guess that's going to be A. Right, okay, so when we get R and A, right, then, yeah, okay, right, okay, what's going to happen here, right, continue is going to go to false. So, yeah, I think let's just sort of write that here. And then what we can say, I guess, well, then we just output not successful. Yeah, alright, I think that should be fine. Okay, hang on. Right, okay, yes, so then B, we want to state the purpose of the algorithm on page 6. Alright, so that's actually what we've said already. Basically checking if strings are palindromes. So let's say, alright, to check if a string, yeah, right, okay, yeah, alright. Okay, so let's say to check if input strings, yeah, okay, let's say that, right, so to check if input strings right, are palindromes. Alright, and I think here we can just explain that. Let's say what the same in forward and reverse order. Alright, and I guess what to, yeah, okay, right, so to output successful or not successful. Yeah, alright, okay, let's kind of say that. Let's say, right, to output whether they were, yeah, whether they were right or not. Yeah, that should be fine. Right, so the next one, we want to explain how the algorithm knows when all the letters in the word have been checked so that it can stop checking. Right, so that's going to be using what this V1 and V2. So we can say what, because V1 is going to increment each time, obviously V2 decrements each time. And when V1 is, yeah, okay, right, okay, yeah, so when V1 is less than V2, well, that's when we've not got to the middle, right? But when V1 is equal to V2, right? Or if v1 is bigger than v2, well, that means we've actually kind of, you know, gone past the middle, right? Therefore, we've actually checked everything. Yeah, so I think we can say that. Yeah, okay. Yeah, let's try and say that. Right, let's say okay, right, yeah, all right. So let's say after each yeah, okay, right. Let's say after each pair of letters. Yeah, right, okay. Although, like, maybe we should say that we're starting from the left. Right. So let's say, yeah, v1. I don't know. Yeah, we'll sort of start from the first character. Right. Let's say, yeah, while v2. Right. V2 will start from the last character. Right, okay, yeah, okay, right, let's say, well, if the characters are different, right, then the algorithm can stop. Right, while if they're the same, right, let's say, well, v1 increments, right, yeah, okay, right, and, okay, we can say the kind of effect that has. Alright, let's say, and it goes to the next character. Right, let's say, yeah, while v2 decrements, right, goes to the previous character. Right, okay, yeah, so let's say this continues. This continues while v1 is less than v2. Alright, and yeah, okay, right, yeah, so let's kind of say why they do that. Right, let's say i.e. Right, i.e. when we haven't. Alright, okay, and actually, I think here we could mention the specific cases for both what even and odd length strings. Right, let's say, yeah, i.e. for even length strings. Right, for even length strings. Alright, what's going to happen? Yeah, okay, right, so let's say, for example, ABBA, right, 4. We said that v1 is going to be 2, v2 is going to be 3. However, yeah, okay, right, yeah, so when they kind of check that they've matched, well, if they match, right, v1 is then going to increment to 3, right, while v2 is then going to decrement to 2, right? So in that case, actually, v1 has now become bigger than v2. So let's say that, yeah, i.e. for even length strings, v1 will become bigger than v2. Yeah, let's say, right, if all characters match. Yeah, okay, yeah, all right. Okay, yeah, let's say maybe if all character pairs match. Right, let's say, yeah, while for odd length strings. Well, let's say, yeah, v1 will be, yeah, I know, yeah, v1 will equal v2. Yeah, when let's say when the middle character has been reached. Right, let's say, yeah, hence, right, we can stop searching. Yeah, okay, right, let's say that, right, okay, we can stop searching, right, since there's only one middle character. Yeah, I know, yeah, therefore it must be a palindrome, right, it's kind of symmetrical. Yeah, okay, right, yeah, alright, let's sort of say that. Right, therefore it must be a palindrome, right, since there's nothing to compare it with. Yeah, I think that sort of makes sense. Then number 7 says the flowchart shows an algorithm that is used to input 50 numbers. Where each number is stored in the variable value when it's input. Any number input that is less than or equal to minus 20 or greater than or equal to 50 is rejected and re-input. The accepted numbers are added together as they are entered, and the total and average of these numbers is output right at the end of the algorithm. Right, and we want to complete the flowchart. Alright, so here is actually a bit tricky. They've given us quite a lot of empty space there. Yeah, so quite a lot we need to fill in. Alright, so if we just think about how we need to do this, right, yeah, okay, right, okay, so here we're just assigning total to, count to 0. Alright, because I guess what we need to count, 50 numbers. Right, of course, well, total, again, they've assigned 0. Yeah, just kind of, well, yeah, right, okay, yeah, okay, that's obviously the total, all the like sort of valid numbers that they've entered. Alright, so I guess the first one, right, probably that's going to be the input. Right, since of course it's this parallelogram, right, therefore input output. Alright, and I think what what we might do is before we just start writing, let's try and make a plan. Alright, since there are a lot of gaps here, and yeah, if you start writing, maybe you're going to make a mistake. Alright, so I think probably the first one is going to be the input. So I'm just going to write that here. Let's go input. Right, if we look at the second one, so I guess, yeah, this, this kind of diamond. Alright, so here they're saying if it's true, well, then that's going to go back and ask them to enter again. Alright, so I think this one, this is going to be if it's invalid. So if, for example, it's less than or equal to 20. Yeah, okay, yeah, alright, yeah, so less than or equal to 20, right, or of course greater than or equal to 50. Right, well, yeah, okay, yeah, so that's going to be the yes condition. Alright, if no, well, no of course means it's valid, right, that's within the range. Right, then think about what we have to do, so 2 process statements. Alright, I guess, well, one is we need to increment count, because of course this is the number of successful, the number of, successful kind of numbers that they've entered. Right, and then, yeah, I guess also we need to add to the total, right, so add this current number to the total. Alright, and then, yeah, there's also going to be one more decision here. Right, so if we say no, then it goes back and they enter another number. Right, obviously if it says yes, well then it finishes. Alright, so I think here, yeah, okay, right, yeah, so that's going to be the one that's checking how many numbers they've currently entered. Alright, so if count is not equal to 50, well then we go back and obviously ask them to enter more numbers. Yeah, I guess if it is equal to 50, right, well that, yeah, then we can stop. Alright, and then I think these two are that's just going to be the output. So yeah, the output total and also output average. Alright, and I guess your average we would of course need to calculate as well, total divided by 50. So yeah, let's sort of zoom in and then we'll try and write all of these. Alright, so yeah, okay, I guess maybe not that much. Yeah, it's kind of like laggy for some reason. Right, okay, so the first one, right, that's going to be input, and I guess what we're just going to input, yeah, I don't know, like input number. They actually, okay, right, yeah, here, right, value. Right, so let's get input value. Yeah, and I guess here, we can also give, yeah, I don't know, we can give them some like message if we want. Alright, so for flowcharts, they do actually let you have the message sort of in the input statement as well. So yeah, I think, I don't know, right, let's go input. Right, let's say, I don't know, enter number. Alright, enter number, and then, yeah, here we have a comma. Alright, and then the second parameter, well, that's going to be the variable, right, that we're inputting into. Right, the next one, so he said what this is if it's in the range. So let's go is. Right, let's go what is value. Right, okay, so yeah, alright, okay, yeah, so since this is the yes condition, so what is, yeah, okay, right, so is value less than or equal to 20, right, or greater than or equal to 50? Yeah, I think that should be right. So let's go, right, less than or equal to minus 20, yeah, or, right, value, what is greater than or equal to 50? Yeah, and then I guess yes, obviously re-enter, right, no. Yeah, no, we don't have to re-enter. Right, so here then count, well that's going to increment, so let's use set. Right, so set, yeah, count, right, 2, I guess, yeah, let's go capital for that. Right, count plus 1. Alright, yeah, okay, right, and actually I think also for increment, yeah, we can also just go increment like this. So if we just go like increment count, yeah, they should also accept that. Alright, of course, yeah, also decrement, if we want to, decrement something, sort of, yeah, minus 1. Right, then I guess total, well, it's just really going to be the same, right? So set, yeah, set total, right, 2, and then, well, that's going to be total plus value. Right, then this one, so this is going to be is, and I guess what is count equal to 50? Yeah, okay, yeah, alright, yeah, so is count equal to 50, right? If it's not, well, then of course we enter more numbers, right? If it is, well, yeah, then we can stop. Right, so let's just output. Right, output, and I guess what is just going to be total. Yeah, I think, is it total, right? Yeah, total and average. Right, let's go total, and then here, let's go output. And then what that's going to be total divided by 50. Yeah, okay, that should be fine there. Right, then we want to explain how you would alter the flowchart in 7a so that it will individually sort each accepted value as it's entered, and then output all the numbers one after another outside the loop that inputs values. Right, you may include program statements or flowchart symbols in your answer, but they must be fully explained. Right, okay, so what is it we want to do again? We want to individually sort each accepted value. right? So I guess that means store it in an array. Right, then output all the numbers one after the other outside of the loop, right? So I guess at the end. Yeah, okay. Right, so I guess what we need to say then, we need to create an array. I guess we need to input each value right into the current index in that array. And then I guess, yeah, after that, after that loop, then of course we're going to need another loop. Obviously, well, just to loop from 1 to 50. Yeah, and then obviously just, output each particular index. Yeah, I think let's try and do that. Alright, so yeah, right, so let's say maybe rather than inputting right into the variable value, we should input into maybe an array. Yeah, I know, yeah, an array of integers. Yeah, and alright, okay, yeah, so I think here we can say maybe array, I know, yeah, maybe of size, or yeah, of, let's say, right, of indexes, right, of indexes 1, let's say 1 to 50, yeah, of integers. Yeah, that should be fine. Alright, and I think what we have to do is we would actually have to start a count at 1 instead. Yeah, I guess, or we would have to actually increment count before we have the input. Yeah, although yeah, okay, right. So I guess we wouldn't actually want the count before the input, since otherwise, if they kind of have multiple inputs, right, because they entered invalid values, well then it means that count would actually increment multiple times. All right, so I think what we can say is rather than initializing count to 0, we can initialize count to 1. Yeah, let's say that. Right, let's say yeah, all right, okay, let's say instead, right, instead of initializing count to 0, alright, we should instead initialize it to 1. Okay, right, let's say, yeah, to ensure the to ensure the kind of array index is valid. Yeah, alright, okay, yeah, alright, so let's say to ensure we don't try to maybe assign the first value to index 0 right in the array. Yeah, I think that's fine, right? So what we've said currently, we're saying we've just initialized count to 0 and we sort of input into the array. Yeah, I think that's going to be fine. And then of course right at the end we can still just check if it's equal to 50. Right, check if count is equal to 50. Yeah, alright, okay, yeah. So let's say now then how do we output? So let's say after the loop, right, we then need another loop. Yeah, alright, okay, and I guess this one, it can just be a count controlled loop. Yeah, okay, right, let's say we need a count controlled loop. Right. Right, yeah, okay, right, so count controlled loop, right, from 1 to 50. Yeah, I think that's fine. Right, and let's say where we output, right, the I guess each each array index's value basically. Yeah, let's say that. Yeah, okay, right. Let's say where we output the number, right, stored at each array index's value. I guess individually. Yeah, all right. So I think, to be honest, I mean that should work. I'm just trying to think, if we can add anything else for 4 marks. Since I've not used up that much space, to be honest. Right, so yeah, okay, right, what we want to do, we want to individually store each accepted value as it's entered and then output the numbers one after the other outside of the loop. Yeah, I mean, I think that's fine, right? So after the loop, we then need a count controlled loop, right, from 1 to 50, where we output the number stored at each array index's value in. Yeah, okay, alright, I guess that's fine. I mean, I think saying each array index's value is maybe not the best. Maybe each array index's position. Yeah, I think that's fine. Alright, and probably we can just sort of add some sort of pseudocode or something here, or I guess flowcharts. Right, let's say EG. Right, let's go output, and what that's going to be, I don't know, like, okay, yeah, alright. So I think rather than saying value, like, let's go values, and then I guess let's just go count. Yeah, I think that should be fine there, to be honest. Right, okay, then for number 8, we want to draw the symbol for an XOR logic gate and complete the truth table for it. Okay, so hopefully this is not too difficult. Just, I guess it just depends if you remember. Right, of course, XOR, well, that's going to be the extra line right there. Then just the OR. Yeah, okay, right there. Then just the OR gate like that. Again, my drawing is not too good. Yeah, why is that eraser not working? Okay, okay, right there. Yeah, there we go. Alright, so probably not that pointy, otherwise that's going to look like a, yeah, it's going to look like a NOT gate. Right, so something like that should be fine. Right, then if we look at the truth table, so of course, well, 0 or 0, right, that's going to be 0. So what we say with an XOR is, yeah, okay, right, so if the inputs are the same, right, then it's going to be a 0. So obviously here, 1 and 1 is the same. Right, if the inputs are different, well, then it's going to be a 1. Right, then we want to consider the logic rules in the following table. Right, so A, right, that's going to be operator not present is 0, operator present is 1. Right, then for B, ignition key present, right, ignition key not present. Right, C, operator code correct, right, then operator code not correct. Right, a crane is a machine with a long arm used to lift heavy objects. The crane will only move if the operator is present, right, and either the ignition key is present or the operator code is correct. Okay, so what I'm going to do, I'm just going to sort of write them here above. Right, okay, so if we say the operator key is present, well, that's going to be this one, right, so that's going to be, yeah. Okay, right, so that's going to be when A is 1, right, therefore when A is true. Alright, so, yeah, okay, right, so here we can just say A. Right, well then, of course, we have an AND. Right, and then, yeah, okay, right, so either, right, of course, this means OR. Right, so, yeah, or the ignition key is present. Right, so the ignition key present is going to be this one. Alright, so that's actually going to be not B. And in fact, I think I'm just going to sort of write it here directly. Yeah, we don't need this kind of intermediate working. Right, so, yeah, okay, right, so I'm going to put brackets just because, well, here there's, two conditions. Right, okay, so the ignition key is present. That's going to be this not B. Right, and then, yeah, so OR, right, or the operator code is correct. Alright, so let's go OR. Right, the operator code correct. Alright, so that's going to be not C. Alright, and that should be like that, right, so just, yeah, A and not B or not C. Right, then we want to complete the truth table for the crane moving. Yeah, alright, and I guess here we're saying, well, moving is, of course, right, this expression here. Okay, so I guess for A, we don't really need to do that, right? Let's go not B. So let's kind of write our intermediate workings here. Alright, so not B, well, of course, yeah, okay, right, so if we go, well, 0, 0, 1, 1, obviously 0, 0, 1, 1, right, therefore it's going to be, well, 1, 1, 0, 0, yeah, 1, 1, 0, 0. Of course, yeah, if we see a 0, it becomes a 1, right, 1 becomes a 0. Then if we look at not C, so not C, well, it's just, yeah, 1, 1, 0, 1, 0, yeah, 1, 0, 1, 0, right, just alternating like that. Right, then we're going to OR them. Alright, so I think, to be honest, let's just sort of copy that here. Right, so, yeah, okay, so if we OR these, of course, if there's at least 1, 1, right, then it's going to be true. So I guess, well, here we've got 2 1s, therefore it's true. Right, obviously 1, 1 is true. Yeah, 1, 1 is true. Right, here we've got 2 0s, therefore it's false. Obviously, yeah, 2 1s, 1, 1, 1, 1, and, yeah, 2 0s. Right, okay, yeah, so then we obviously want to do this, right, then we just AND it with A. Alright, so here, of course, we're looking for when both of them are true. Now, if we look, right, we actually see, well, these first 4, of course, these are all going to be false. Alright, so yeah, okay, so we can just quickly write, 4 zeros in there. Right, then if we look at this, right, so here we've got, well, obviously 3 1s, and of course, well, obviously, yeah, 4 1s here. Right, therefore, well, 1 and 1, 1 and 1, 1 and 1, and then obviously this last one, 1 and 0. Right, therefore, that's going to be a 0. Right then, number 9, a database table capital cities stores data about capital cities from around the world. So, right, we've got the fields, the identification, a unique identifier, right, the primary key, right, name of the city, country, the name of the country in which the city is located, right, continent, again, well, the name of the continent where the, country, city is, population, number of people living in the city, founded, the year the city was founded, right, obviously average income, right, in dollars rounded to 2 decimal places, right, and subways, so whether or not the city has an underground railway station. Right, and we want to complete the table by writing one appropriate field from capital city for each data type, and each field must be different. Right, okay, so if we say Boolean, of course, we're looking for a true or false, so I think that's going to be the subway. Yeah, because obviously, well, whether or not the city has an underground railway, so of course, well, true or false. Right, so here, let's just go subway. Right, if we look at integer, and I think, yeah, okay, right, I think actually, let's try to get all of these. So integer, I guess, well, one is going to be the population. I guess, yeah, also the year founded. Alright, so I think, yeah, those, yeah, okay, right, so either of those two is going to be fine. Right, then if we look at real, so I think, well, that's just the average income. Yeah, there's nothing else. Right, yeah, average income. Right, then if we say text, right, so I guess, identification, like, probably that's going to be text. I mean, yeah, okay, right, so to be honest, here it's not necessarily going to be text, but I mean, probably. Alright, however, I think, yeah, okay, right, okay, so if we look at these three, of course, yeah, any of those, well, they're definitely going to be text. So yeah, name the city, right, country name or continent name. Right, then B, we want to complete the structured query language or SQL statement to list only the name, country, and population of all the cities in the capital city table from the continent of Asia. Right, so yeah, okay, so let's see what we want to select. It's well, name, country, and population, so we can just go there. Right, let's go name, right, country, and population. Of course, we're just separating those by commas. Right, okay, yeah, alright, okay, right, then we say, well, something capital city, well, that's just going to be from. Yeah, alright, and hopefully people remember the structure of these SQL statements. Right, when we have a select, well, we say select, right, then the columns or kind of the functions that we want to select, right, then we say from, so well, from, and then, the table name. Yeah, and I guess, well, then we can have obviously where, we can have order by, yeah, I guess, well, something like group by, yeah, although I think group by is AS, to be honest. Right, so where, and then, right, that's going to be capital city. So is it capital, okay, right, hang on, no, it's not capital city. Okay, right, yeah, hang on, right, okay, that's going to be continent. Yeah, I didn't really read that correctly. Yes, okay, so where the continent is Asia. Right, so continent, and of course, well, Asia, right, that's going to be a string. Yeah, alright, that should be fine. Okay, and then I guess that's all they have for that one. Then the last question, which is question 10, the 15 marker. And actually, for some reason, this question was actually removed from the paper. I think everyone that did this paper got 15 marks. Actually, I'm not entirely sure why it was removed. I've heard, different reasons given online. Alright, so if anyone does know, the actual specific reason why this was removed, yeah, then I guess just, let people know in the comments. Right, anyway, let's read what it says. Right, so a program is required to allow students to calculate the volume of a number of standard three-dimensional shapes. It will use functions to allow other shapes to be added in the future. Right, so I guess, well, cuboid, well, the volume, right, base times depth times height. Right, triangular prism, right, so we're half base times depth times height. Yeah, I guess just half of the one above. Right, then sphere, so that's, well, 4/3, well, then pi, yeah, pi r cubed. Alright, and it's saying, well, pi is a constant with value, 3.142. Yeah, okay, alright, and actually I've just realised here that actually we technically don't even need to rewrite this formula. We can actually just do a half of, the cuboid function. Yeah, so I guess we could reuse that function kind of if we wanted. Right, then it says, write a program that meets the following requirements. Output a menu to ask the user for an input to indicate the shape for which volume they need to be calculated. Right, from the three shapes given, or if they want to stop the program. Right, the program must validate the input. Alright, so I guess probably we can just give them a menu with options, 1 to 4. Or of course, well, 1 being what the cuboid, right, 2 being the triangular prism, 3 being the sphere, and then 4 being exit. Right, then 2, we want to input the data needed to calculate the volume of the chosen shape based on the given formulae. Right, calculate one function for, create. Right, create one function for each shape to calculate and return the volume using the given formula. Right, each function uses the input data as parameters. Alright, so yeah, I guess that's the key thing, right? We actually want to pass what the base, the height, the length, pass that into the functions as parameters. Right, then we want to output the volume in the main program rounded to 2 decimal places. Right, the program continues until the user inputs the stop operation from the menu. Right, yeah, you must use pseudocode program code and add comments to explain how your code works. Right, so this is kind of different where here they say we actually do need to declare variables and constants. Yeah, whereas usually they don't. Right, and yeah, also all inputs and outputs must contain suitable messages. Alright, so let's just go ahead and do this, and yeah, I've copied the instructions already. Right, so I guess the first one, we can probably just declare this constant pi. Yeah, generally it's a good idea to declare your constants at the top. Right, so let's go pi, and yeah, I think for for IG, right, we just use the assignment operator, right, to assign a value to a constant. Right, and I guess then, yeah, right, so here then we want to declare all of our variables. So I guess first we want the menu choice. Of course, just, 1 to 4, right, sort of what the user chooses. Right, and then I guess everything else like, length, height, etc. Right, they're all going to be reals. So I think let's just go integer, and then we can probably declare the others now. Right, so yeah, what is it we need? Right, okay, we need base, we need depth, we need height. Right, is there anything else? I guess also radius. Alright, and all of those, yeah, they're all going to be real. Yeah, and I think, okay, alright, so I guess maybe we can also, so maybe we can also have the volume, right, we can just store that. Although I guess we don't really need to, because we can probably just directly output that, to be honest. Yeah, okay, alright. So I think probably the volume, less not, well, yeah, okay, alright. Alright, okay, yeah. So here I'm going to include it. Now, the reason I'll include it is because basically if we store the volume, right, then we actually don't have to copy the round, the round function 3 times. Alright, we can just, assign the sort of shape, the shape volume, right, to this volume variable. Then we can just output the volume rounded, 1 time. Kind of after the user menu. Yeah, I think that's fine. Alright, so what we need to do then, well, we just need to repeat everything until the user enters 4. So let's just go that right. Let's go repeat until, and that's going to be what? Until the menu choice is equal to 4. Alright, and then inside here, well, this is where we're going to ask the user to enter the menu choice. And I guess it says we also need to validate it. Alright, so we're also going to need another loop that's basically just validating that it's between 1 and 4, right? There are options. So I think let's have an output here. Right, okay, yeah. Although actually here I'm thinking that if we have to show the menu twice, right, that's going to be quite long. I think maybe the second error message, right, we can just say, I don't know, yeah, error, please enter a value 1 to 4, right? We don't really need to show the menu choice again. Right, so yeah, what I'm going to do, I'm just going to go on a shape, shape volume calculator. I mean, you don't really need this kind of title, although I'm just going to put it. Alright, and to be honest, what you'd want is in the exam, well, you then just want to get output. Obviously, you have, sort of option 1. Right, that's going to be, that's going to be what the cuboid. Cuboid volume. Right, of course, yeah. Then you'd want to get output to, right, triangular prism volume. However, I'm just going to do it here, right, just as a kind of multi-line string. And the reason I'm going to do that is because basically on the site, that will then all output, in the input prompt that pops up. Right, whereas if we have multiple outputs, well, then only the most recent output will actually pop up, on that input prompt. Although I guess, all the outputs will appear here, right, in the output terminal. Right, okay, so cuboid volume, right, 2, that's what, triangular prism. Let's make it like lowercase. Triangular prism volume. Right, 3, that's going to be the sphere volume. And then 4, well, that's going to be exit. Right, then we just want to input that into menu choice, and right here then is where we can just have a while loop. So let's go while, and right, while menu choice is less than 1, or menu choice is greater than 4. Right, let's go do. Right, and what we want to say, I don't know, let's go output. Right, let's say error. Right, let's go on a menu choice should be between 1 and 4. Right, let's say try again. Right, and again, let's just input into menu choice, and yeah, that should be okay. Right, okay, yeah, so here then we could just have, if statement, right, so yeah, if, else, and then obviously, nested ifs. However, I think since we have 4 options, then probably a case statement is going to be better. So yeah, let's go case of, and right, the thing we're checking is going to be the menu choice. Right, okay, yeah, so if the choice is 1, well then what I guess we can do, we can just ask them to input, what is it, the base width height. So let's go output. I know, yeah, enter base length, or okay, yeah, I guess, yeah, base length is fine. All right, base length of cuboid. Right, then we're just going to input that, and right, that's going to be into base, and then I think I'm just going to copy this because it's basically the same thing. Right, and then I guess, what is it? Right, okay, depth. Right, let's go enter depth of cuboid. Right, and then I guess just height. Yeah, that should be fine. Right, so yeah, okay, right. So now what we want to do, we want to create the different functions. So yeah, I'm just going to go here. Right, let's go function, and I guess, I don't know, let's call it like cuboid, right, cuboid volume. Right, and here we're going to take in 3 parameters. So yeah, all right. I think what I'm going to do, let's go, I don't know, BDH. Yeah, or yeah, okay, right. Or I guess you could also call it, I don't know, base depth height again. Right, base depth height, let's go real, and here, right, let's go returns, and of course it's also going to return a real. Right, and I think, yeah, okay, so here we can do this just in one line actually. Let's go return, and what this is, well, of course, the base times the depth times the height. Yeah, sort of quite simple there. Right, so what we then want to do is we just want to assign that to volume. So let's go volume, and we're then going to assign the cuboid volume, right, the parameters, right, of course, well, that's going to be these inputs that they've typed in. Right, so that's going to be base, depth, and height. Yeah, that should be fine. All right, and then I think we can basically just copy that because, I mean, yeah, okay, so number 2 is really going to be the same. Right, so here I guess it's going to be what, triangular prism. Right, so what's the formula for that? I think yeah, okay, right, it's the same, right, but then just half. All right, so that's quite easy. Let's just copy that. Right, so let's go, I don't know, triangular prism volume, and I guess, yeah, okay, all right, I guess let's do all of this, and then we can then just divide that by 2. Yeah, that should be fine, and then here, right, let's go triangular prism volume. All right, and then, yeah, actually, I'm going to copy this one. Right, and then let's say for number 3, well, that's just going to be the sphere. Right, okay, so the sphere, well, that's just going to need the radius. Yeah, okay, right, yeah. Yeah, so just the radius, because of course, well, pi is going to be constant. Right, so enter the radius, right, of the sphere. Right, then we can just, yeah, delete those. Right, let's sort of copy this again. Right, let's go sphere, yeah, sphere volume. Right, so here we're only taking 1 parameter, of course that's going to be the radius. Right, so this one, I guess, right, okay, yeah, alright, so it's going to be what, 4/3. So let's go that, right, so 4 divided by 3. Right, okay, then we want to times pi, and then I guess what, times radius cubed. Alright, so yeah, okay, right, okay, so we could go, well, radius times radius times radius. However, if we want cubes, yeah, okay, right, then for IG, I guess cubed is going to be this one. Yeah, the caret symbol. Yeah, I think that should be okay. And then, right, so here it's going to be the sphere volume. And I guess the parameters is just going to be the radius. Yeah, that should be fine. All right, and I think for 4, yeah, right, okay, all right. So what I'm thinking is that actually if we have an output kind of after at the end, well, we also don't want to output the volume, you know, if they enter 4 as well. So probably we just want like an, yeah, okay, right, so probably we want an if statement just to check if they enter 4. Alright, and if they do enter 4, well then we don't want to actually output anything. Alright, so I think actually we don't really need a case for if they exit. Yeah, we don't really have to do anything, right, if they exit. So let's just go end case like that. Alright, and then, yeah, what I was trying to say is basically here, we just want to output. Alright, but we only want to output if they didn't enter option 4. So let's get if menu choice is not equal to 4. Right, okay, yeah, so then what we want to do, let's go output. Right, let's say, I know, yeah, volume for shape. Right, and then so here, this is where we round, and I think it said to 2 decimal places. Yeah, okay, right here. So rounded to 2 decimal places. Right, so what we're going to take then is going to be the volume. Right, of course we rounded there to 2 decimal places. Right then, if we just go end if, and I think that should be everything. Alright, so let's just read it again, make sure we've got everything. Right, output a menu to ask the user for an input to indicate the shape for which they want to calculate the volume. Yeah, okay, I think we've got that. Right, validate the input. I mean, yeah, we've got that right obviously here. Yeah, I mean, hopefully there's no mistakes on that. Right, input the data needed to calculate. Yeah, based on the formula. Yeah. Create one function for each shape. Yeah. Right, each function uses the input data as parameters. Okay, and then yeah, output the volume in the main program. Rounded to 2 decimal places. Alright, so yeah, okay, so I think now, I mean, hopefully that's going to work. Let's just test it. Right, so in fact, actually, yeah, okay, so let's go 0. Alright, yeah, it's going to say error, menu choice should be 1 to 4. Let's try 5, again, error. Right, so let's try 1. And yeah, alright, so, okay, yeah, okay, so let's try and choose values that we know. For example, if we go 10, and then depth of 10 and height of 10, well, that's going to be what, 10 times 10 times 10. And then yeah, okay, so here we get 1000, right, which seems correct. Right, then let's go 2, and I think if we go 10, 10, 10, right, and this should be 500. Yeah, because of course we get half of that. And then, alright, yeah, so this one's going to be a bit difficult. Let's go 3, and let's go radius of the sphere. Alright, again, let's go 10. Yeah, and okay, yeah, so I think if you do the calculation, yeah, then I think this should be the right value here. Right, and let's go exit. Okay, yeah, and then it just exits like that. Alright, and I guess what we could do is we could just have some, like, I don't know, yeah, goodbye or something at the end. Yeah, let's say goodbye. Alright, and let's run it again, and let's just go 4. Yeah, okay, right then, of course, it just says goodbye when they exit. Alright, so I think here we've actually got everything. Then, of course, we just want to go back and add some comments. Right, so here, let's say, alright, and yeah, okay, I guess we could actually just say right here, like, let's say initial declarations. Of course, yeah, the other 15 markers we haven't had to declare. I think this is the first 15 marker where they said you actually do have to declare. Right, so here I guess what we can say, well, repeat while they don't choose to exit. Yeah, alright, okay, let's say, I know, continue, yeah, continue asking for new shapes, right, until they choose to exit program. Yeah, that should be fine. Right, I guess here we can just say, I don't know, show menu. Right here we can say what validate, or yeah, okay, alright, yeah, so let's say range check. Right, ensure, I know, yeah, ensure menu choice, right, is 1 to 4 inclusive. Right, okay, I guess what we can say, I don't know, calculate volume based on menu choice. Yeah, okay, let's say that, maybe let's say, right, input, right, let's say, I know, your input shape parameters. Yeah, I guess let's say, okay, yeah, let's say input shape parameter values. Yeah, or let's say required, based on the menu choice, right, or shape, yeah, they chose. Yeah, I think that's fine, right, and then, okay, let's say this one here. So what this is if they don't choose to exit. So yeah, I guess if they don't choose to exit, right, then let's say, yeah, then I don't know, show volume, yeah, show volume for that shape. Yeah, that seems okay. And then I guess here we can just say, I don't know, yeah, functions to calculate volumes for specific shapes. Right, yeah, okay, let's say that 3 functions to calculate volumes for specific shapes, right, based on the input parameters, or yeah, I guess, yeah, based on their parameter values, right, their arguments. Yeah, or let's sort of say that, like, parameter values. Yeah, okay, I think that's fine. Alright guys, so as always then, I mean, hopefully that video is useful. Any questions, just ask in the comments, and I'll see you again in the next video.